Hello, my lovely viewers. Welcome again to Mathematism Now. It is your favorite presenter, Jeff Nino, and today we shall be looking at the topic differential calculus using product rule. Now, in our last video, we were able to see how we can use chain rule or functions rule to solve differential calculus problems. And don't forget, we said in our last class, chain rule has just one function, and the function is u. But today's class we shall be looking at how we can use product rule in solving differential calculus. Now, first of all, product rule involves two functions, and these two functions are known as u and v. Okay, it is known as u and v, and it has a formula for solving product rule. And the formula for product rule is dy over dx is u dv plus v du. Okay, u dv plus v du. Where u dv means hold u, differentiate v. Hold u, differentiate v. And v du means hold v, differentiate u. Okay, so we shall be using this formula in solving these two questions that we have on the board. The first question says y equal to 6x raised to the power 3 plus 4 and 2x squared minus 6, we should find the derivative of this function. And then the second question says y equals to 10x raised to the power 4 into the bracket of 7x raised to the power 3 plus 7. Now, don't forget we said from the beginning of the class that product rule is made up of two functions, and that these two functions are multiplying each other from the word product. Product means times. Okay, so for you to apply product rule, it must have two functions, and that these two functions are multiplying each other. Now, if you take a look at question number one says y equal to into the bracket of 6x raised to the power 3 plus 4 and 2x raised to the power 2 minus 6. Okay, now if you take a look at this question very well, you will notice that I have two functions. Now this is the first function and this is the second function. And you will see that these two functions are multiplying each other because you have a bracket here. So whenever you have two functions multiplying each other, you apply product rule. Okay, now how can we solve using the formula I gave? Now, the first function is u and the second function is v. Okay, now after this, what do we do? Let us introduce the formula I gave to you. The formula is dy over dx is equal to u dv plus v du. Now remember I said u dv means hold u, but differentiate v. Now when you say hold u, it means 6x raised to the power 3 plus 4. I won't differentiate it. I will write it. I will bring it out. 6x raised to the power 3 plus 4. I won't touch it. But we are told to differentiate v. Now this is our v. Our v is 2x squared minus 6. Now if we differentiate 2x squared minus 6, we are going to get this. 2 times 2 gives us 4 and 2 minus 1 gives us 1. No need to put the 1 because there's 1 there. Now when I differentiate 6, I will get 0 because my 6 is a constant. So there is no need for me to include what? 0 to it. So it means if I should differentiate 2x squared minus 6, I will get 4x. Now, plus. Now the next is hold v. Hold v. Now, if I hold v, my v is 2x squared minus 6. It means I won't touch it. I will bring it here. 2x squared minus 6. But we were told by the formula to differentiate u. Now, our u is 6x raised to the power 3 plus 4. Now, if we should differentiate 6x raised to the power 3 plus 4, we are going to get this. 3 times 6 gives us 18. 3 minus 1 gives us 2. Okay, now when you differentiate 4, it will give us 0 because 4 is a constant. So if I should differentiate 6x raised to the power 3 plus 4, I will get 18x squared. So now that we are done differentiating, what is the next thing we are going to do? We will open the brackets. Now when we are opening the brackets, everything here will times what is inside, and everything here will times what is inside of that bracket. Now let's times. 6 times 4 gives us 24. And x raised to the power 3 times x gives us x raised to the power 4, according to the laws of indices, which says if this is 3 and this x is carry 1, when you add times, you add the powers. So 3 plus 1 here gives us 4. Plus 4 times 4x gives us 16x, because 4 times 4 is 16. Now we've opened this bracket, now let's open the other. Plus 2 times 18 gives us 36. And x raised to the power 2 times x raised to the power 2 still gives us x raised to the power 4 because 2 plus 2 is 4. Why is it possible for me to add 2 and 2? Because the base are what? The same, xx. Minus 6 times 18. 6 times 18 will give us, okay, 6 times 8 will give us 36, 42, 48. Then put up 8 carry 4. Then 6 times 4 will give us 6, plus that 4, 10. So I have 108 x squared. Okay, so now if I have this now, you will notice that in this question, this x here is carrying power 4, this x here is carrying power 4, the powers are the same. So because the powers are the same, it means I can work with 24 and 36. They can be added. Now, 24 plus 36 will give us 60. So we're going to be having 60x raised to the power 4, okay, minus 108x raised to the power 2, then plus 16x. So this becomes the final answer to this question if we should differentiate 6x raised to the power 3 plus 4 and 2x squared minus 6 using production. Okay, to get a better understanding about this question, this is what we are going to do. We are going to solve question number 2 again using this same pattern, and then you will see that you get a better understanding of what I did in question number 1. Without wasting time, let us begin question number 2. Okay, question number 2 says y equals to 10x raised to the power of 4 into the brackets of 7x raised to the power of 3 plus 7. Again, you will notice I also have two functions, the one outside the bracket and the one inside the bracket. And you will notice that these two functions are multiplying each other. So without wasting time, it means the one outside the bracket is u and the one inside the bracket is v. Now introducing the formula which says dy over dx is equal to u dv plus v du. Now we already know what u dv means. U dv means hold u differentiate v, and v du means hold v differentiate u. Now, if I hold u is 10x raised to the power 4. But if I should differentiate v, our v is 7x raised to the power 3 plus 7. If I should differentiate 7x raised to the power 3, I will get 21x raised to the power 2. How? 3 times 7 gives me 21. 3 minus 1 gives me 2. And then if I should differentiate 7, I'll get 0 because 7 is a constant. So it means if I should differentiate 7x raised to the power 3 plus 7, I will get 21x squared. Now, plus, now I'm holding v constant. What is my v now? My v is 7x raised to the power 3 plus 7. But what am I differentiating now? I am differentiating u. And what is u? 10x raised to the power 4. Now, if we should differentiate 10x raised to the power 4, we will get 40x raised to the power of 3. How is that possible? 4 times 10 gives us 40, and 4 minus 1 gives us 3. So this is what I'm going to get. Now, when we are done differentiating, what did I say the next step you take? You what? You open the bracket. Now, opening the bracket, we will have this 10 times 21 gives us 210. And x raised to the power 4 times x raised to the power 2 will give us x raised to the power 6 because 4 plus 2 is 6. Plus, now everything here multiply what is outside. So now 7 times 40, 7 times 40 will give us 280. Then x raised to the power 3 times x raised to the power 3 will give us x raised to the power 6. Because 3 plus 3 is 6. Now plus 7 times 40. 7 times 40 again will also give us 280. But this time it will be 280x cubed. Because why? This 7 is not carrying x, so the x cubed comes down here. Now again, you will notice that the power here is 6 and the power here is 6. So it means I can work with 210 and 280. So without wasting time, 210 plus 280 will give us 490. So here becomes 490 x raised to the power 6 plus 280 x raised to the power of 3. So this is the answer you will get when you find the derivative of 10 x raised to the power 4 into the bracket of 7 x raised to the power 3 plus 7 using product rule. So class, we have been able to use to solve how we can use product rule in solving some differential calculus functions. So for more information, please don't forget to look at the description below, and also don't forget to share our videos, don't forget to subscribe to our channels, and don't forget to like. Please also leave a comment section when you are done with the class. In our next class, we shall be looking at how we can use quotient rule in solving differential calculus. Till we meet again in our next class. Thank you very much.